Alright guys, so last two examples. We're going to look at number 7 and number 9. Again, if you want number 8 and 10, those examples will be right below this link in the completed notes section. It's where they'll be uploaded. So number 7 is a good one because it's talking about piecewise functions. So our first equation, f of x equals, or y, equals 4x plus 2. Well, this is true when x is less than -1. So I'm going to start by graphing this like a normal line. So we're starting up 2 on the y-axis, and my slope is 4. So I'm going up 4 to the right 1. And I can't repeat that again, so I'm going to do the opposite, starting at that first point, our y-intercept of 2, and going down 4 to the left 1. I'm going to do that again. Down 4 and to the left 1. Okay, so I got a total of 4 points. Now, before I draw my line, I only care about the x values less than -1. So at -1 on the x-axis, I have a point here. Well, less than -1 means it does not include that value. So instead of a solid dot, I really need an open dot less than. I need an open dot at -1. From that, I want the numbers less. Well, less than -1 is -2, -3, -4. So as I go to the left of that point, my graph is going down. So there's my piecewise function. I do not care about those points above because those are at 0, which is greater than -1, 1, which is greater. And we only said that this graph happens for less than -1. So that's the first piece of our graph. The second piece, I'm going to draw in a different color just to make it a little easier to see. So I'm going to use blue. The second piece, f of x, or y, equals -3 times the absolute value of x plus 3. We're going to graph it just like we've been graphing earlier. Well, this is a positive 3 inside the absolute value. That means I have an h value, my vertex, is at -3. Well, since there's no value following the absolute value, nothing on the outside, that means my k value is 0. So my intercept, this graph starts at -3, 0. And by this graph starts, I mean the vertex of this graph starts at -3, 0. Okay, well, my slope of this graph, the slope, I can't see my line. The slope is -3. So this graph, negative means I'm going down 3 to the right 1. Down 3 to the right 1. The opposite of that would be down 3 to the left 1. Because remember, absolute values make a V. So down 3 to the left. So I've only got 5 total points for that absolute value. Well, our domain is the x values greater than or equal to -1. Well, at an x value of -1, I follow that all the way down to this point right here. Because it's greater than or equal to, it's going to be a solid point. Well, greater than that, if I'm following my function for the absolute value, it goes down. So it's really small, but it goes down. So I do not care about the points smaller. The other blue dots that actually show our V. Because we only want the greater than -1 points. So we have a very small piecewise function is what I'm saying. But that's it. They don't ask for the domain or range. That's our graph. So even though we have an absolute value equation, it's not within our domain, so it looks like a normal piecewise function. Okay, the last possibility is number 9. Notice this time we have an inequality, less than or equal to. So we graph it like normal, an absolute value. I have an h value. The opposite of positive is a -4. And my k value is -6. So my vertex is -4, -6. Left 4 and down 6. Right about there. Okay, there's my vertex. There is no a value in front of the absolute value. There's nothing there. So that means my slope, my a, is 1. So I'm going, because it's not a negative in front, there's nothing there, up 1 to the right 1. Up 1 to the right 1. Keep that going. Woo. Keeps going. So that's the right side of my V. Well, the left side would still be up because I'm making a V, but to the left because it's absolute value, so it's making a V. Up and to the left one, up and to the left one. Okay, so I'm going to connect those points. Now, our function is less than or equal to, so that's how I know I can make a bold line. If it was just less than, we'd have to make that dashed, so that still applies. It's a bold line because of the less than or equal to. Now, less than, because remember, inequalities mean we have a range of values. Less than really means we need some shading. So decide where we're shading. Less means below. So we're going to shade below our absolute value function. So everywhere below is where our values fall. So the solutions to this inequality are any point below the absolute value. I hope this was helpful. Again, if you want more examples, click on the link below, but this is it. You're ready, set, go. Have a good day. Come stop by if you need anything.